Hey guys, it's Juan again, and today I'm going to show you how to analyze quadratic functions. So all the quadratic functions have the form ax squared plus bx plus c, with a, b, and c existing in the real numbers, and a cannot be equal to 0. The domain of all the quadratic functions is all the real numbers. There's something very particular about the quadratic functions. It is the fact that if a is positive, it opens up, and if a is negative, it opens down. Now let's talk about the vertex. So the vertex is a point, and it has its coordinates at h, k. Now we can just calculate h, which is negative b over 2a, and k is going to be equal to the function at h. So we just sub in the value that we get for h in the function, and we just get k. Let's talk about the intercepts. If we want to find the x-intercepts, we just solve ax squared plus bx plus c is equal to 0. Why is it equal to 0? Because at y equal to 0, so just the x-axis, so y is equal to 0 is all like this entire line, and we're just gonna get like two different points, say one here and one here, or we can get a single point, or we can get no points, but we're gonna look into that later. Now if we want to find the y-intercepts, we just sub in the value of 0 to the function in here. So f at 0, it's just c, because well, if this is 0, this would be like 0, and this would be 0, and well, we would just end up with c. Now solving this equation is not always easy. Sometimes we can factor, but sometimes it gets a little bit more complicated. So we can just apply the quadratic formula, which says that x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So b squared minus 4ac is called the discriminant. The discriminant is important because it will tell us how many zeros does a quadratic function have. If the discriminant is positive, we're going to have 2 zeros. If that discriminant is 0, we're just going to have 1 zero. And if the discriminant is negative, we're going to have no zeros at all. If the discriminant is positive, we're going to end up with two different values, which are just the square root of the discriminant, and we can find it because we can find the square root of a positive number, you know? Now, if the discriminant is equal to 0, we're just going to end up with a single 0, because this will all become 0, and we're just going to end up with 1 0, which is going to be negative b over 2a, which is just going to be equal to the vertex. So the vertex is going to touch the x-axis. Finally, if our discriminant is negative, we're going to end up with the square root of a negative number, and we know that that's an imaginary number, so we're not going to end up with a real solution. So it doesn't touch the x-axis because we have no 0. Let's try an example. So let's try y is equal to x squared minus 2x minus 3. Let's start. So the domain is equal to all the real numbers, or if that's the notation that you want to use, or we can just say that from negative infinity to positive infinity. They are the same thing. They're just different ways of writing it. A is equal to 1, b is equal to negative 2, and c is equal to negative 3. Since a is equal to 1 and it's a positive number, we know that the parabola is going to open up. Now let's find the vertex. So the vertex is a point hk. And if we want to find h, we know that h is equal to negative b over 2a. Now let's sub in the numbers that we get here. So negative 2 over 2 times 1. So this 2 cancels out with this 2. We end up with 1. And this negative cancels out with this negative. So we end up with positive 1. That's our answer for h. Now let's find k. So we just have to sub in the value that we get for h in our function to find k. So k, or y, that is equal to k, is equal to 1 squared minus 2 times 1 minus 3. K is equal to 1 squared is 1 minus 2 minus 3 minus 2 minus 3 is minus 4 minus 5 plus 1 is minus 4. So k is equal to negative 4. Now let's find the y-intercept. Now we know that our c value is it's going to be our y-intercept. So this is our y-intercept. Now let's find the 0. So we just have to solve x squared minus 2x minus 3 is equal to 0. Now let's try factoring it out. So the way I factor this types of expressions is I just put parentheses, and since there's no number in front of x, I just put x in here and x in here, and my first sign is going to be the exact same sign as my second coefficient, so it's negative, and the sign that I put here is this sign times this sign, so it's positive. Now we're looking for two numbers that multiply together give us -3 and added together give us -2. So those numbers are 3 and 1. So -3 times +1 is -3, and -3 plus 1 it's -2. Let's recall that if a times b is equal to 0, we have two options, whether a is equal to 0 or b is equal to 0. So if we make this our a and this our b, then we know that x minus 3 is equal to 0, or x plus 1 is equal to 0. So we have a value of x equal to 3 and a value of x equal to -1. Those are going to be the zeros of our quadratic function. Now let's make sure we get two zeros, so let's try the discriminants. So b squared is -2 squared is 4, minus 4 times a is 1, so I'm not going to put it in there, times c is -3. So 4 minus times a minus is positive, 4 times 3 it's 12. And that gives me 16, which is a positive number. This is greater than 0. So since the discriminant is a positive number, we're going to end up with two different values, which is what we found here. Finally, let's try sketching the function with all the data that we already collected. So we know that our zeros are going to be 3 and -1. So I'm not going to draw a scale, but let's pretend this is -1. And 3 times that to this side is going to be 3. So 1, 2, 3. Our vertex, which is at +1, -4, so +1, 1, 2, 3, 4. Here's going to be our vertex. 1, 4. Finally, we have our y-intercept, which is -3. So 1, 2, 3, -3. And we know that our parabola is going to open up. So it's gonna look something like this. So yeah, that was it for this video. I really hope it was helpful and you liked it. And if you did, please give it a big thumbs up and don't forget to subscribe. And I'll see you in my next week's video, okay? Bye. It's beautiful.